Okay, part two. So it's just the second half of that first, well, actually, second quarter of the first page. We had just finished with two complementary angles in number two. They add to 90. That's what this equation's all about. There's a picture of it over here to the right. Get the x value and sub it back in to get the actual angles, measure of each angle. Number three is I have two angles. You have to look at the QRT, traces out one angle, TRS traces out another, and it gives you an expression for each you see over to the right. I'm going to take those out of there. But you have then a third. The whole angle is 3x plus 18. That's QRS if you trace that out. And once you have all those labeled in there, then you can see the relationship is that the top one and the bottom one add to the third one. So that's what you see to the left here. Solve that and you get x equals 3. And that's not the whole story in a lot of cases, but for this one it does say just find x, so you can move on. Next, number four is same picture, but it gives you new expressions for QRT, new expression for TRS, and then it says if RT is a bisector, an angle bisector, then go solve for x. Well, that means that the top angle and the bottom angle are equivalent or congruent to each other. So we can set them equal, and I've done that here. And then we go ahead and solve 6x equals 36, and then x equals 6, and that's all we're looking for in this one, find x. Then the next piece, if we look at number 4 again, here it is, there's x equals 6. Then number 5, another form of setting equations equal or adding them to something. This 3x plus 4 and 10x minus 3, hopefully your eyes say, ooh, vertical angles, those are congruent. Because in here it says, okay, find the measure of ABC. Tell me how you did it. So what you're going to do is, yeah, those are vertical angles. Yes, you're going to set them equal in this case, and you're going to solve for x. And then it says, how do you know this? You want to write in vertical angles. There's a postulate we have for vertical angles. So you can just say, that's why I can do it. These are vertical angles. X equals 1 is great, but I want ABC, so I need to put that back in. And then find ABC is 7 degrees. I know, kind of tiny, but roll with it. Unless I made a mistake, you let me know. Next one, find x in number 6. The reason is going to be linear pair. These two add up to a line. They make a straight line. So what allows me to say, now these aren't equal, but they do add to 180. So we kind of have a nice, the number 3 was about adding two angles and making a third. Number 4 was about setting them equal because they're bisected. Number 5 was setting them equal because it's vertical angles. Number 6 here is adding these two expressions to an equal, setting it equal to 180 because they're a linear pair. Solve that and get x equals 11. That's all we're finding in that problem. And then the last one is yet another combination. M is the midpoint of Kn. So Kn is just a segment. That's notation for a segment, by the way. Kn, those two letters means a segment Kn. So there's Kn, K at the end, and here M is the midpoint. All that describes to you is that the sides, either side of that midpoint is the same length. And so that means we can set those equal, 9x minus 20 equal to 5x plus 4. You see it to the right here. Solve for x, x equals 6. The question, though, says find Kn. So I need to put x in here on the left and get 9 sixes or 54. 54 minus 20 is 34. You can either put x in on this side and do it again, or you can just say, oh yeah, these are the same. If that's 34, this is 34. So all together it's 68. This is the second page, 8 through 13. It's all about these parallel lines on the right here. And then the difficult part isn't putting in the angles. You know, if 115 is here, this was 65 in number 6. The first question asks for angle 1, which is up here, and it says, what's the reason? That's really the important part about this 8 through 13. How do you know that angle 1 is 115 and the lower one's 115? Aside from them both being obtuse angles, and you know in parallel lines and one transversal, the fact that they're both obtuse makes that 115, but the real reason is called the alternate exterior angles theorem. We know alternate exterior angles with parallel lines and a single transversal, you know those are equal. And then the next one, this is the order I took. I went from 115 in the lower right, did number 1 by alternate exterior. I did the one next to it, number 2 is 65 by linear pair postulate, because I know those make a line together. And then I went vertical angles to get number 3. And then I went linear pair to get number 4. And then for number 6, you can do alternate interior by using number 3, or you can go linear pair by using 15 there and get 65. And then finally, number 7, you can either use vertical angles from number 6 or linear pair from the 115. So there's a lot of options there, but what's important is that you justify where that came from. You know that's either 115 or 65. The acutes are, it's pretty easy to tell, and I recognize that's an important skill too. You know, the congruent vertical or acute angles and then the congruent obtuse angles are all the same. Okay. Now I didn't bring home the angle labels for you guys for 14 to 17, and that way I'm unable to actually fill those in for you. But what I do know is these are parallel lines. What you want to focus on is all the angles on one transversal are either supplementary or add to 180 supplementary or are congruent to each other. You can compare all those as long as they're on the same transversal. The other transversal, you can compare all the angles there. They're either supplementary or congruent. But you never want to go between transversals. You never want to compare any angles over here on the right, or top, versus any of the angles over on this transversal. Don't compare those. There's no way to do that with the information we have. So either equal or add to 180 for those angles there. I'll have that posted, the actual key to it. Let me know if you need a video explanation, but I'll go ahead and post the paper key of that a little bit later. You can see that in action. But I can do 18 with you. 18 is whether or not the triangles can be proven congruent, and yes, these two can. First thing you do is take the given information and you mark it up. So GK to ML, mark those. GKM, the angle, that's GKM, and then LMK, those two angles are congruent, so I marked them. You can see that in my pencil markings on the actual sheet. But just always fill in the givens. And then your job is to say, are they congruent? Yeah, we got side, angle, side. That matches between the triangles. And I just look at one triangle and say, what do I have that matched? There's side, angle, side. The congruent statement is to say which two triangles are congruent. So GKM, that triangle, is congruent to LMK. And you have to go in the right order so that the appropriate matching corners line up. Because I know that upper K corner and that M corner are congruent, and they have to be in the same place in the congruent statement. So that's where M and K are both in the middle and congruent. All right, next page. Yeah, these are all pretty quick here. So 19, mark the givens. S and R congruent. XT bisects SXR. I know that's been an issue, bisecting. XT bisects angle SXR. This XT is splitting the angle into two congruent parts. I already marked it in pencil. I'll leave it there. Just using the given, if you don't even stretch it, you can say, what matches in that triangle? What do I have that lines up? Well, I have an angle, and a side, and that's one of our 5 options. And if you don't know those, get your note card out. Put in your side, angle, side, your angle, angle, side, your side, 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 angle, side, angle, and hypotenuse, leg. Those are the 5 you want to make sure. Those are the only ways to prove triangles congruent. Remember, angle, side, side does not work, or side, side, angle is a no-no unless it's a 90-degree angle. That would be called hypotenuse leg. Next one, 20. Given that H is the midpoint of both diagonals here, that means that these are equal, and then these are not the same as the other diagonal per se, but they're equal to each other. They're split in half. That's what a midpoint does, splits the whole segment into 2 equal parts. Then there's vertical angles, of course, and with just all those markings in there, you can see I've got side, angle, side for my congruence. In both cases, in the last 2 pieces, remember you have to state what 2 triangles are congruent, and you want to line up all the corners that match. So look carefully at my congruent statements and notice that they go in a particular order, like MHQ is the same as KHD. It lines up matching parts. You trace over them in the same order. Okay, 21. Given that TP is perpendicular to AS, that means you got to put a 90-degree angle in that corner. It hits at 90 degrees. AP congruent is SP. There. And what we do from there is don't go too wild, but this is a classic hypotenuse leg. The hypotenuses match and a leg matches between these right triangles. And then again, here's the 2 triangles that are congruent. Very carefully, it is ATP, and in the same order, STP on the right-hand side.